Hello everybody, welcome to this video, Launch Program in Java, Problem Solving and Software Design, Java. Well, I assume that you already know the syntax and variables, the basics, at least the fundamentals of Java or object-oriented programming or any programming in general. This is just trying to problem solve, not really a programming session. But if you are struggling to solve problems or stuck in tutorial help, then I suggest that this video or the series might help. So let's solve a simple problem. And to program is to solve. Programming is just a tool, any programming language. It's the programmer who gives meaning to all of this. So instead of diving into the syntax head first, we can take some time to think about a problem where we use Java as a tool, just like we use pencil as a tool to write or create or draw. So simple problem. Finding which of the two numbers is bigger. So we can use George Polya's problem-solving method. He has even written a book, How to Solve It. It's a really good book and I highly recommend reading it. Not only for computer science, but pretty much any problem you have in life. So he has four problem solving step by step, 4 steps. The first one is to clarify and determine the problem to solve. Second one is to make a plan. Third step is to execute the plan. So execution here we talk about coding it. And then fourth is review or reflect. And which is also really important because as a programmer, you shouldn't just write code, you should also look for ways to optimize and refactor the code. Now let's look at step one, understand the problem. So what is the problem? To find a solution, you have to learn to ask good questions. You have to be you shouldn't leave room for ambiguousness. Just like mathematics, you should know what you're doing because the computer doesn't like ambiguity. So here, what is the problem? Let's just dig a little deep. I don't think we need to dig that deep for a problem like this, but it's good to practice anyways. So the problem was we need to find the largest sum numbers. That was pretty vague, right? So how many numbers? Let's say 2 numbers for now, but it can be any number of any amount of numbers, right? And what format are these numbers in? We've probably learned in high school that there's decimals, integers, natural numbers, rational numbers, irrational numbers. Like there's many types of numbers, or at least there's decimal and there's integers. The computer. So what are we trying to compare? Let's say integers here. Let's just keep it super simple. And yeah, what does determining mean? Like what like in English for yourself, tell yourself, rewrite the problem. It's just say if number 1 is bigger than number 2, then the first number is the largest number. Or if B is larger than A, then B is the largest number, right? That's what we're trying to figure out. That's what we need the computer to analyze and tell us. So now that we understand the problem, we can look on making a plan. It can be anything. You can write in your own words in English, in your own language, pseudocode, drawings, cryptic, binary code, anything as long as you understand how to execute the algorithm. That is the step-by-step manner in which we try to solve the problem. Let's try first try to plan it in English itself. But be warned, as I said, we cannot be ambiguous. We can't be weak. We have to be as precise and systematic as possible, even if it's just a plan. So let's say we store one number, the first number we need in the computer memory. Or we could just say we store the first number in variable A, because variable is just a space we kind of create in the memory of the computer in the RAM for the number, and then we can do the same for the second number, variable B. And if A is bigger than B, then A is the largest number. If B is bigger than A, then B is the largest number, right? And we display this largest number on a human readable format. So by display, I mean print it out on the terminal. So let's, you may also, like I said, you may also use other methods. You could dig a little deeper. You could even try to uh, do some input output, just write down in a notebook how it would look like, or you could just start coding. Doesn't matter. Just take some time, you know. But as your tech with Tim would say, paper is cheap, but code is expensive. So use as much as paper as you want. Third one is to implement a solution. Here is variable x at PPT for now, and jump straight to IntelliJ. I have my IntelliJ here, and let's start with plan. Plan was, we have a variable a, so we have an integer a, which let's just say 1, yeah. Integer b, let's do 3, yeah. And then it said if, so you compare it, right? And it's a conditional. So whichever condition meets it, we print that out, right? So conditional 1 was if a is bigger than b, then print via, no, my bad. A is bigger than b, then print the largest number is plus else. So if it doesn't, if a is not the biggest, then it automatically goes to else. So then we print smallest. The largest number is b, and that's it. That is what we need to do. Oh, let's check it out and see if it works. See, now we have 3. If we do this as 3 and this as 1, then we get 3. We can do 4, we can do 4,000, it doesn't matter. Now we've given it, we don't need we can automate this task. We don't need to like look at the numbers and like go through our heads. The computer will take care of it. So great, we have created a simple comparing comparing which is the largest number in Java. And there's always the, sorry, now that we implemented the solution, we can always stop, but we can also review and reflect on how could we make this more interesting or more easier. How could we optimize it or like upgrade this, because there's modules, right? There's also the max method, or yeah, for the math module. We can also use that. That will make it easier. What would you change if you change the question up a bit, like the smallest number? Or what if both of them are equal, then what would it print? You can always like play around it a bit, or like take a little bit step further. That's how you learn to program. You iterate and you get a little bit better every time. That's how you program. And is there another way of doing the problem? It's going to be simpler. All of these are valuable things to look into. So, thank you for watching, and I hope it helped. Call me if you want to learn how to think and code.